The world around us, it feels so real, right? Solid, stable. It's just there. That's probably the biggest assumption we all make every single day. But what if it's all wrong?
I mean, think about it right now. You're sitting somewhere, maybe in a chair, the floor is solid under your feet. That feeling is the bedrock of how we see everything. It's just common sense, isn't it?
And yet, here's the crazy part. The smartest people on the planet, the ones who spend their entire lives trying to figure out what reality is, they're not so sure anymore. In fact, they're starting to think that our whole common sense picture is just, well, wrong. Okay, so let's break this down. On one hand, you've got what we feel, our intuitive reality. Things are solid, they exist whether we're looking at them or not. But on the other hand, we've got what physics is telling us, this bizarre quantum reality, a world that seems to be built on pure probability, where just looking at something seems to snap it into existence. And that clash right there is what we're going to get into. So here's the plan. First, we'll look at the glitches in the code, so to speak. Then we'll get into the whole mystery of the observer. And finally, we'll see what kind of mind-bending picture of the universe all this data is painting. Let's go. All right, first up, glitches in the code. So what do I mean by glitches? Well, for about 100 years now, physicists have been running experiments, and the results are just weird. They're totally incompatible with the idea of a solid, objective world out there. And here's the kicker. These aren't just wild theories. These are hard experimental facts. The first big clue is something called the measurement problem. See, the math of quantum mechanics doesn't describe tiny particles as little billiard balls. Instead, it describes them as a wave function, which is basically just a cloud of pure possibility. They don't have a specific location or a specific speed until, you guessed it, someone or something measures them. The best way to see this in action is the famous double-slit experiment. It's a classic. If you shoot a particle at a wall with two slits in it, and you don't watch which slit it goes through, it acts like a wave. It literally goes through both slits at the same time and makes this wavy pattern on the other side. But, and this is the wild part, the second you put a little detector there to see which slit it went through, poof, it snaps into being a particle, picks one slit, and the wave pattern disappears. Just looking at it changes its behavior. How crazy is that? So what is this wave before we look? That's the wave function. And it's so important to get this. It's not a physical wave like in the ocean. It's a wave of pure mathematical probability. It's basically the universe saying, here are all the things that could happen. Before we look, reality isn't made of facts, it's made of possibilities. And listen to this. This quote is from Werner Heisenberg, one of the absolute giants of quantum mechanics. He's the guy who came up with the uncertainty principle. And he's saying, flat out, the atoms, the particles, the stuff that makes up you and me, they aren't real in the way we think. They're a world of potential, not of actual things. Now, for years, scientists tried to find a way out of this weirdness. They thought, okay, maybe the particles have secret properties, hidden variables that we just can't see yet. It was a nice idea. But then a bunch of incredible experiments based on Bell's theorem just slammed that door shut, for good. They proved that, no, the properties we measure literally do not exist before we measure them. They're just not there. Okay, buckle up, because if you thought that was strange, this is where it gets truly mind-bending. There's this experiment called the delayed choice quantum eraser, and it suggests that it's not just the present that depends on being observed, it's the past too. Get this, a particle can finish its journey, hit the detector, and a choice we make after it has already landed can change whether it behaved like a wave or a particle back in time. Yeah, you heard that right. The physicist who came up with this, John Wheeler, put it perfectly. He said, the past isn't really the past until it's been registered. It means our choices right now, today, might be reaching back in time and cementing what actually happened. The past isn't fixed until we look at it. Okay, so all of this points to observation being a huge deal. But that leads to the next big question. What exactly is an observer? What does it take to collapse that wave of possibilities? This is a famous puzzle called the von Neumann chain. Think about it. A measuring device is made of atoms, right? So it's quantum too, which means it's in a fuzzy state of possibility until it's observed. And the computer screen connected to it, also quantum. The light hitting the scientist's eye, quantum. You see the problem? It's like a line of dominoes that never falls. Where does the quantum fuzziness stop and the real world begin? Well, the guy who came up with this problem, John von Neumann, had a pretty radical answer. He argued that there's only one thing in that entire chain that isn't just another physical quantum system: the conscious mind of the scientist. His conclusion? It's consciousness itself that breaks the chain and makes reality, well, real. Now that is a wild idea, and it forces us to think about a totally different way of looking at reality. It's a path that, believe it or not, a lot of the founders of quantum physics found themselves going down. So, how do you make sense of all this? A past that isn't fixed, things that pop into existence when you look at them, consciousness playing a key role. You can't fit that into our old model. You have to flip the whole thing on its head. And that flip is from what's called materialism to idealism. So, materialism is the standard view, right? Matter is the basic stuff, and somehow consciousness just bubbles up from it. Idealism turns that completely around. It says no, consciousness is the fundamental thing. And the physical world, matter, space, time, the whole shebang, that's what emerges from consciousness. And again, this isn't some fringe idea. This is Max Planck. He's literally the father of quantum theory. And his conclusion was that we've had it backwards this whole time. You can't get behind consciousness. It's the starting point. Matter is what comes from it. John Wheeler, who we heard from earlier, had this great phrase for it: it from bit. The idea is that the most fundamental level of reality isn't stuff, it's information. Every physical thing gets its existence from a bit, a yes or no answer to a question, which happens when an observation is made. And what's really incredible is that modern physics is starting to back this up. You have things like the holographic principle, which comes from studying black holes, and it suggests our entire 3D universe might just be a projection, a hologram. And what's a hologram? It's information projected to look like a thing. It lines up perfectly with it from bit. So where does this leave us? After all these paradoxes, all these glitches, what is this new worldview? What's the bottom line here? Okay, here are the big takeaways. First, think of the reality you experience as a user interface. It's not the deep down code of the universe. Second, looking at something isn't passive. It's a creative act. You're not just measuring reality, you're helping to make it. And all of this seems to be pointing to one incredible conclusion: that mind, not matter, might just be the foundation of everything. So this leaves us with a huge final question to think about. We've always pictured ourselves as just living in the universe, like tiny spectators watching a movie that was already playing. But what if that's not it at all? What if we're not just spectators? What if we're participants? What if every time you look at something, every question you ask, you're actually helping to bring the universe itself into being? The science, as strange as it sounds, is pointing in that direction. And if that's true, well, that changes everything.